Hello everyone, this is Professor Kuehn. Apparently my last video was having some technical issues, so we got cut off at the end. So what I'm going to do is I'm going to finish this lecture that I was doing, this introductory lecture on Galileo's dialogues concerning two new sciences. I was giving a brief overview of the kinds of things that Galileo is going to be talking about and that we'll be talking about in this physics course. So remember, the two main topics he's covering are the strength of materials and falling bodies, but he has a number of digressions. And so last time I left off at Galileo's interested in the question of, does nature permit a vacuum, and if so, how does that contribute to the cohesion of materials? He's also interested in the question of falling objects. That was one of his two new sciences, and he's basically going to be speaking against a lot of the ideas of the famous Greek philosopher Aristotle, whose ideas were very popular not only in ancient times, but all the way up through the Middle Ages, and they're actually experiencing somewhat of a resurgence today. So specifically, Aristotle is interested in falling objects, like Galileo is, and Aristotle had this idea that when you drop a ball, the speed with which it falls is proportional to the weight of the object. So for example, if you drop a lead ball, it's going to fall with some speed, some maximum speed. And if you drop another lead ball that's twice as big and hence twice as heavy, it will fall twice as fast. That's roughly speaking the opinion of Aristotle. Galileo is going to reject this idea, or at least modify it to a large extent. Another issue that Aristotle relating to falling bodies is Aristotle believed that the medium through which you drop an object has an effect on the speed of the falling object, which makes sense, right? So when you drop an object in air, it tends to fall quickly. When you drop it in water, it falls more slowly, and when you drop it in honey, for example, it falls even more slowly. So Galileo is aware of this, that Aristotle's basically correct, but Aristotle had the notion that the speed of the object that was falling is inversely proportional to the density of the material through which it falls. And Galileo is going to attack this particular mathematical description of falling objects in different media. Another topic that we are going to come across in reading Galileo is the question of how does the period of a swinging pendulum bob depend on the weight of the bob and on the length of the string from which it is hanging. So for example, if I pull a pendulum back, it's going to take some period of time to swing forward and back, and he's interested in how you adjust that period of swinging time. He's also interested in the topic of why is it that certain musical tones are pleasing to the ear while others are not. So if you hit certain combinations of notes on a piano, they sound pleasant, the major chord, minor chords, and so on. But if you pick out 3 random piano keys and strike them together, they will not sound pleasing. This is not just a cultural thing, by the way. So there seem to be certain cross-cultural recognitions that certain notes sound good when hit together. So Galileo is asking the question, why is that? And what specifically is it about those combination of notes that are pleasing? Is there a way to understand this? He's also interested in the relationship between the force that it takes to hold an object stationary on a ramp and the speed with which it accelerates after it is released. So you might imagine holding a block stationary on a slippery ramp and using a string, so kind of holding this block up using a string to prevent it from sliding down, and it's going to take some force to hold it up. And then when you release the string, it's going to accelerate down the ramp. And the question is there a relationship between the force it took to hold the block up and the subsequent acceleration it feels on its way down? And another topic he's going to talk about, and this is the second of his new sciences, is what is the trajectory of a cannonball when fired? And he's going to mention that everyone's aware that when you shoot a cannonball, it moves in a curved trajectory, but he's going to mention that it's not only a curved trajectory, but it's a very specific curved trajectory, namely a parabola. He calls it a semi-parabola, half parabolic motion. And how, in turn, how can you shoot a cannonball so as to maximize the range that it fires? So these are just some of the topics that Galileo is going to be discussing. We're going to come across a lot of very interesting discussions that Galileo embarks on in the course of studying his dialogues concerning two new sciences, and I hope that you have as much fun going through this material as I do in studying it. So I'll see you next time.